Okay, so what we're going to do is we're going to say, well, since cos alpha is equal to adjacent divided by hypotenuse, so now I'm looking at the bottom triangle. I have very little regard for the top one in order to aid in simplifying things a little bit further. I'm only going to look at this bottom triangle for a little bit, and I'm going to look at it in terms of the relationship between the adjacent and the hypotenuse and the angle alpha in here. So what I'm doing is I'm saying, well, cos alpha we know is adjacent and hypotenuse. The adjacent is AF, and we can see that going here. That there is the adjacent, it is AF. And as a result of it being the adjacent, let's clear this up a bit. It's a little bit too hectic in there. Let's clean that up. There we go. Nicely done, perhaps. The adjacent of our triangle is that, because we're only looking at alpha. The hypotenuse of the triangle is this. There. And labeling has just occurred as a result. Adjacent is AF. Hypotenuse is AE. And one thing we've learnt about alpha is it is not only chilling in this left-hand corner in here. That's not what it's doing. It is also chilling up here in terms of it being the exact same size angle. And be aware these diagrams are not to scale, but that is definitely to say that these two are the same. And again, just to remind ourselves why that is because we have suggested it's committing changes. Please be aware it's committing. Some of these pictures are said to be relatively high resolution when you consider the degree to which this laptop is not one with an elaborate processor. It's committed far too much change, and I've also made a very strange, I've also done something very strange, and then I've coloured the whole thing pink. I'm not sure what that is trying to represent about myself. Let's pull that back. And now I have the list of the folders. Okay, this has gone very strange. Go away. There we go. Right. We do not need that. There we go. So here we have that other angle in there, and that is the equivalent of alpha as well. Now what we're going to do, however, is we're just going to consider, rather than in adjacent divided by hypotenuse for these two, what might be more interesting is to do adjacent divided by hypotenuse for there. That is the adjacent, and the hypotenuse is there. Okay, if that is true, then we can just substitute. Instead of saying the adjacent is AF, the adjacent is BD. Instead of saying the adjacent is hypotenuse, let's be more specific. The hypotenuse is just BE. And so we have that cos alpha is BD over BE. We can move forward with that by saying that, considering that, we already knew that BE was sine beta. We already knew that BE was sine beta. We've had a conversation about that here. There it is. This is where it's manifesting itself. Let's highlight that and remind ourselves of that. BE was sine beta. The reason sine beta was opposite divided by hypotenuse. We were looking at this triangle here. We said that as a result of beta being in this corner, the opposite was over there. So we can, if I can move it, there's the opposite BE. The hypotenuse was this length here, which was 1. So there is a length of 1. So sine beta was just opposite divided by 1, which meant that sine beta was just opposite. And I don't think I made it too specific in the labeling, but this was sine B. Therefore, when we get to here, then I can also, let's get to this diagram here. And particularly, let's do it up here. I'll put it in here, sine B, like so. Let's also put the other things that we've considered. We also learned that this was cos. Now, cos what? Let's remind ourselves exactly what it was. It was cos B because it was the cos B is, or cos is equal to adjacent divided by hypotenuse. That is the adjacent line, and again, adjacent is 1. So this was cos B placed in here. So I'm going to add that information as well, just to remind us going forward. So here I'm going to move this back. Here I'm going to put that this, please do not forget that it's cos B. We'll do one last label, bear with me, we're nearly done. One last label that we gained was this one in here. If I scroll up slightly, that sine alpha cos beta was EF. Sine alpha cos beta was EF, just to make you aware of where that came from again. where we can go through past videos if you're fully in a position of not being aware as to where that came from. But the idea was that sine alpha was opposite of our hypotenuse, and with some basic substitution you can get sine alpha cos beta is EF. So I'll also place that in here. I'll say this is going to be sine alpha cos beta, and we have this information. We've been building up slowly labels of each side as a result. Let's do this one here. This one will be the last one before we can start putting things together and start tackling the problem. Since BE is sine beta, then cos alpha, remember what we were dealing with here, we were dealing with cos alpha, so we can, there's the adjacent side and there's that, and we said we were looking at cos alpha, and I said to you, well, what can we tell about cos alpha? Well, cos alpha, the adjacent is AF, right? That's the case, and the hypotenuse is AE. But that's if you're looking at the bottom angle for cos alpha. Remember, it is the same cos alpha up here. So actually, the adjacent is BD, as I've said, cos alpha of BD, and the hypotenuse is sine beta. As you see, this label I've already put in here, the hypotenuse is sine beta. So, with a bit of multiplying both sides, I can take this and I can times by sine beta on this side, and I can times by sine beta on the other. These will cancel out to produce 1, giving you cos alpha sine beta is equal to BD. And this is a very important one because this allows us to almost complete our conversation as to how you end up with quite a useful formula to represent the double angle. Remember, the double angle is for quite a specific triangle. Just to recap that concept, the double angle is for this triangle in here, when that is the two angles, alpha plus beta. There is the adjacent opposite hypotenuse. We've gone on quite a bit of a journey, but bear with me, and if you've stayed this far, well done. The idea is now that I can absolutely put this label BD in here. That's what we've got, cos alpha sine beta. So I'll try and put it across here. We've got cos alpha sine beta equals, if I go back one, equals that BD length in there. Okay, so recall. The reason I said recall is because we're now going to wrap things up. We're going to go back to the very beginning. Recall what? Recall that sine beta plus alpha is not, because it's sine, it's just opposite divided by hypotenuse, and the BC, we can get a nice big line in here and let's get red. BC is this. Hypotenuse is AB, and sine beta plus alpha is therefore analyzing this triangle in particular, wherein the idea of the opposite of it is there, nice bright and purple. There's the opposite of that triangle. There is the hypotenuse of that triangle. And finally, we have that as the angle, alpha plus beta or beta plus alpha. And so we've been more specific. Opposite BC, hypotenuse AB, labeled. Notice one thing though. Notice that BC can be broken down. It can be broken down into BD plus DC. And I'm going to do that. Instead of saying BC, I'm going to say, actually, y'all need to recognize that this can be written as that. It can be written as BC plus BD. And of course, hypotenuse is AB, so I'm going to keep that as is. Also, DC can be said to be equal to EF. What do I mean by that? I mean that this length here must be the same as this length here, right? And so there I have it. I'm going to say, well then, why not make that change? Instead of having DC, I'm going to have EF, like so. And so now I have this formula. I have the idea of this right angled triangle. When considering the opposite side and the hypotenuse side, there is no reason why we cannot write it like that. And that is so far what we have.